Good afternoon, everyone. In this video, I'll be discussing about peer-to-peer systems. We'll be looking at basic peer-to-peer characteristics and generations of peer-to-peer systems and peer-to-peer distributed computation and Napster and its legacy. Okay, this is the outline for this video. With the peer-to-peer systems, the main goal is to enable the sharing of data and resources on a very large scale. Okay, so we want to share this data and resources, okay, among the peers, okay, at very large scale. We want to eliminate any requirement for separately managed servers and their associated infrastructure. We don't want to have any centralized servers or something, or separately managed servers. We just want to use the resources of individual peers and want to use them for sharing the data and the resources, and at a very large scale. That's the fundamental idea what peer-to-peer was pushing. The main reason is scope for expanding popular services, okay, by adding to the number of computers hosting them is always limited. Say for example, there is one popular service, okay, so if it is really getting popular, you can add, say for example, initially you start with 10 servers, then you will add more servers, say for example, another 10 more and another 10 more and another 10 more. This idea of horizontal scaling actually is pushed a lot by cloud computing domain also, okay. But of course, like there is always a limit to the amount you can actually scale up. Of course, now today with all these sort of new technologies, cloud computing promises like you can actually have infinite number of resources. Still, there is a limit to the amount of scalability you can actually achieve there. Okay. Say for example, when all the hosts are to be owned and managed by the service provider, then it's a big problem. Okay. Similarly, like then most of the time will be actually lost for the administration and fault recovery cost. Okay. So these are the things like which will actually dominate. Assume like you have an application server which is actually replicated over 1,000 servers, okay, and that is a service which we are providing. Managing that one is a little bit difficult. Of course, today there are certain companies which actually manage that one. Say for example, services like Google, etc. Okay, but for most of the general applications, scaling up to that level and then like being able to support from one center is pretty difficult. Okay, you also have to think from the, say for example, from the network perspective. Say for example, assume all your application servers are in one central data center, okay, so then network bandwidth that can actually be provided to this sort of single server site, okay, is also a major constraint. You cannot basically provide infinite amount of bandwidth to that particular data center. Okay, this is not possible. So these are the things which have actually driven peer-to-peer technologies. Peer-to-peer technologies originally came around 1999. Okay, so and then like they had their own share, okay, of peer-to-peer applications. Of course, today the time is for cloud computing and these things which actually promise infinite amount of resources where you can actually add as much as resources whatever you want, and managing these things is also relatively easy. Okay, if not at this infrastructure as service level, but at platform as service level and then like software as service level, okay, it's relatively easy to manage thousands of servers. Okay, but of course that goes into a completely different direction of discussion. Okay, coming back to the peer-to-peer discussion only, purely peer-to-peer discussion only. Okay, so managing such things at individual servers is a big problem. Then why don't you basically use the capacity of individual nodes? That's what peer-to-peer system is basically pushing the idea. Peer-to-peer systems thus aim to support useful distributed services and applications using data and computing resources available in the personal computers and workstations. So that's the difference. Okay. Even for a generic discussion, cloud computing is the one which is actually pushing that there is somebody who is owning infinite amount of resources. You can rent as much as you want and you can actually use them as your system or services basically grow. Whereas peer-to-peer basically pushes like, okay, so there are thousands of peers, okay, so take the help of their individual personal computers and workstations and try to solve a problem, okay, or like you try to use it for an application, or say for example use it for the data exchange, etc. So the peer-to-peer applications are as defined by Shirky into peer-to-peer applications are those applications that actually exploit the resources available at edges of the internet. Say for example, at the edge of the internet, you will be using the stories of a workstation which is really at the edge of the internet. Okay, you will be using the CPU cycles of a desktop at the edge of the internet. You will be using the content owned by individual people, and of course, like human presence as well. This is what the definition which was provided about peer-to-peer applications way back in 2000 by Shirky. So peer-to-peer application design actually ensures that each user contributes resources to the system. So these are some of the critical characteristics of a peer-to-peer system. By design, like they actually ensure that each user contributes some resources to the system. And all nodes in the peer-to-peer system have the same functional capabilities and responsibilities. Okay, it is not like so each one is dealing with different activities. Okay, of course, like the amount of resources that they are bringing to the system may differ a little bit. Peer-to-peer system, their correct operation does not depend on existence of any centrally administered systems. So they don't need like any other servers which are actually managing all the things, all the P2P system completely. Okay. By default, in ideal cases, these are the characteristics of a P2P system. They can also be designed to offer a limited degree of anonymity to the providers and the users of the resources. Say, for example, if there is a peer-to-peer system and then like assume like you are exchanging files, okay. So these peer-to-peer systems will also provide you a limited degree of anonymity. So it can hide who the providers are, who the users of the resources are. Okay. A key issue for their efficient operation is the choice of the algorithms that they use basically for the placement of the data across the host. Okay, and of course, like once you have this sort of data stored across this host, subsequently you need to access it as well. Okay, these algorithms actually balance the workload and ensures the availability without actually adding extra overheads. Okay, so these algorithms basically take care of it. And these algorithms will also consider like these peers can join or leave the peer-to-peer system anytime. These are some of the critical characteristics of a peer-to-peer system, and these are some of the considerations we should always keep in mind. There are several generations of peer-to-peer systems which we have seen over the years. Okay, primarily there were three generations of peer-to-peer systems. Okay, and of course, like relevant application deployments can also be identified. The first generation was launched by the Napster Music Exchange service. Okay, so in this application, like people were actually exchanging music files. Okay, Napster, it was really popular. We already have discussed some basics about it. We will also talk about it further as part of this video. The second generation of these sort of file sharing applications actually offered greater scalability, and of course one of the very important thing they started looking at is anonymity. Okay, so they were trying to anonymize like who the providers are, who the consumers of the resources. Okay, and of course like also looked at fault tolerance approaches. Some of the well-known examples are this sort of Freenet, Gnutella, Kazaa, BitTorrent, etc. These are about the first two generations, Napster and then like generic file systems. Okay, then the third generation is actually characterized by the emergence of these sort of middleware layers for this sort of application independent management of distributed resources, and of course at a global scale. Okay, so these things actually provided different algorithms, different solutions, more or less like they provided platforms for application independent management of these peer-to-peer resources. Some of the well-known examples are Cord, Pastry, Tapestry, etc. So let's look back at the Napster system. This was originally, as I mentioned, like it is actually used for file sharing. Okay, and people were actually exchanging these sort of music files, but it had actually a centralized and replicated index. So whenever like here are all the peers, okay, so which are connected to Napster. Okay, so and an example, let us think about that. And then like there were several Napster server indexes. So index 1 is here, index 2 is here. Okay, and of course like which had list of all these sort of music files and with which peers like it had. So whenever like a peer wanted to download a particular music file, what it had to do is like first it has to locate this sort of locate this file on which of the peer it has. It has to first locate that. Okay, file location request. So which will be actually given to this sort of Napster server index. That will actually return you all the peers that are actually offering that file. Then you will be choosing one of the peers, and then like you will be actually asking that particular peer for that particular file. And once the file is delivered, okay, then the index is actually updated. So first the file you will be directly downloading between the peers. See, only for searching the index you will be actually approaching the server, but for downloading, like you will not be downloading it from the server. So if you would have downloaded it from this Napster server, then that becomes like a single point of failure. Okay, so basically like it will put a lot of load on this server. Instead, being a peer-to-peer application, the file request, you can actually request one of the piece and you can actually get it delivered. But of course, like once the file is actually delivered here, whatever the copy you asked, okay, from this machine also had that particular copy. So you actually have to update the index, okay, at the Napster server. So that was the last step which was actually happening. Okay, so these are the shared resources at the edge of the internet in terms of storage is concerned. Napster became very popular music exchange soon after its launch in 1999. At its peak, like there were several millions of users who were actually registered there, and thousands of them were actually swapping these music files simultaneously. But of course, like that means like people were actually exchanging music files which are actually copyrighted material. So eventually, Napster ended up with these sort of legal proceedings. Okay, and eventually they had to close it down. Okay, Napster couldn't argue that they were not involved with the information that is actually being exchanged, but they were actually only providing the services. But in fact, actually, they provided this sort of registry, so this sort of index that itself actually made that they were the ones who were actually advertising it. That actually made them okay. They could not win the legal proceedings and they had to shut it down. This actually pushed that for the peer-to-peer based systems, anonymity of these sort of receivers and the providers is a very critical thing. Okay, so whoever are sharing this particular data, okay, hiding their details became like one of the major concerns for the sort of designers of the next generation peer-to-peer systems. Okay, so a lot of these sort of mechanisms for anonymous communication, okay, that are actually resistant to most forms of traffic analysis have also been identified, and now they are actually available in the most of the peer-to-peer systems which are existing today. Okay. Of course, like if files are also encrypted before they are actually placed onto the servers, the owners of the servers, whoever is actually distributing them, of course, can plausibly deny that any knowledge of the contents. Okay. Of course, that is also one approach. But of course, like adding any of these solutions will actually add a lot of cost to the resources. Basically, like in terms of like amount of processing that is to be done, and then like amount of data which has to be stored. Okay, you will basically incur additional costs. But one good thing what Napster has done is Napster has actually demonstrated the feasibility of building a useful large-scale service that actually depends almost wholly on data and computers owned by ordinary internet users. See, the music files were owned by individuals. The computers, the desktops were owned by individuals. Okay, they are actually exchanging the files. And first time like Napster has actually demonstrated that a very interesting application can be built just by utilizing these resources at really the edge of the network. So as Shirky has mentioned, the edge of the resources can be storage, processing, and of course the people themselves along with the content as well. Napster had provided further contributions, okay, for the next generation P2P systems. Say for example, like whenever somebody is trying to offer a music file, which is really short of song, and he is the first one, his computer will be spammed with all the requests from all the peers. Okay, Napster took several approaches to avoid this one. It basically considered the number of hops between the client and the server when it was actually allocating a particular server to a particular client request. Okay, this simple load balancing distribution actually enabled like the service could actually scale to large users. Okay, so basically like say for example whenever you are trying to ask for a server, okay, it basically tried to provide you link to a server which is close by for you. Okay, it is not like okay, so for example you will be routed immediately to a server which is in US or somewhere. Okay, so it basically considered about number of hops it basically has to go through in terms of the internet is concerned. Regarding the other things, Napster actually used a replicated unified index of all these available music files. We have already seen like it has several index files, okay, servers where like all these things are actually shared. Okay, so that means like it was actually synchronizing whatever the contents which are there on this sort of index files. Okay. For the application which they have considered, that is exchange of music files, the requirements for this sort of consistency between these replicas was not very strong. And of course, like we are talking about the systems which are around 1999. Okay, so at that time, like replicas, okay, maintaining the replicas and solutions were not so strong. Even for this application, like it was not that much required. Today, if you build any particular application, these applications may actually require like high consistency. between these replicas. Okay, so we need to identify proper solutions for that. Of course, unless the access path to the data object is actually distributed, object discovery and addressing are likely to become a bottleneck in peer-to-peer based applications. Okay, this is also like was shown by Napster. So that's about like the stories. For peer-to-peer can also be used for this sort of distributed computation. One of the very well-known example for that one is this sort of SETI at home. Okay, the basic idea of these particular type of applications is to exploit the sort of spare computing power on end user computers. Okay, so they have these sort of free cycles. Okay, so which can actually be used for doing interesting computations. Okay, that is one of the idea of peer-to-peer distributed computation is concerned. Okay, one of the very well-known examples for that one is SETI at home project. This was basically targeted at searching for extraterrestrial intelligence. Okay, so it was basically trying to search for aliens. So the fundamental idea is like it was actually trying to get this sort of digital radio telescope data, okay, and it was actually trying to partition a stream of this data in 107-second work units. Each of these work unit will be about of the size 350 kilobytes, okay, and it actually takes these files and it actually distributes them to these sort of client computers whose computing power is actually contributed by these sort of volunteers. Okay, and of course like these files, okay, and of course like people are trying to find like this sort of significant signal patterns, okay, so that like it can actually detect like any extraterrestrial intelligence. That was the basic idea. And of course like these files were actually distributed redundantly across 3 to 4 personal computers, okay, to basically safeguard it against like any erroneous or like malicious nodes or etc. So it is not just sending that particular file to only one computer and then like it is basically trying to get results out of it. It is also replicating the processing, okay, to see that the results are actually correct. Of course, again in this particular application, the distribution of the work units and the coordination of the results is actually handled by a single server. Okay, so that means like these were the first generation of peer-to-peer systems. So just like Napster also like it had a central index, okay, server index, which was actually giving the information of those particular peers where these files are existing. Similarly, in this case, like you will actually reach a server which will actually coordinate about distributing these work units and also like getting all the results. Okay, and it's of course like responsible for all the communication with all these clients. Once each and every machine actually calculates the results, okay, the results are actually communicated to this central server in a very short message. And SETI at home, this project and then like this peer-to-peer application, okay, for distributed computation became like very popular. Okay, there were even hundreds of thousands of nodes who were doing these parallel calculations, okay, at certain point in time. So around 2000s. So regarding the references are concerned, now we have started with chapter 8, okay, of our course, okay. So that is like chapter 2 of unit 3. Regarding the reference are concerned, this is actually a material from Distributed Systems Concepts and Design by Colores et al. And the material is actually taken from chapter 10 of this particular book. Thank you very much for your attention.